Okay, so good evening again to you all. This evening we'll be looking at advanced data processing. I tagged it and transforming raw data into machine learning ready format. And on that today we'll be looking at skewness, missing values, outliers, and then encoding. Encoding. Okay, so and these are the things we'll be looking at, as I've said. Why data processing matters. We're dealing how to deal with skewed data, how to undo missing values, how to detect outliers, how do you undo those outliers also, and how to encode your categorical data. For those that were at the class yesterday, for the beginners, I told them computer works in what? With numbers, zeros and one. And for every time you want to use a data for a computer, they must all have what? A distinct data type. It's either they are all integer or they are all strings or they are all Boolean. But when it comes to machine learning, if you are not working with images, you are working with what numeric data. When we talk about categorical data, we are talking about data that is not what numerical. So how do we encode? How do we make this model to see a categorical data as what as a numeric data? All right, let's go on. So this is what we just want to look at today. You have raw data. You want to undo skewness. You want to undo missing values. You want to undo outliers. You want to encode features, just like a categorical data, and prepare them ready so that now you can use them for what? For your models to build your models. Remember, we are talking about what? Advanced data processing. We are now in the intermediate class, so we'll be doing more than just what we do, drop rows and what we were doing before. But now we'll be doing more. Okay. So introduction. Why data processing matters. I said data processing transforms raw data into a clean, usable format for machine learning model. So you can see it there. So I have a raw data, which I've read in, which is my raw data. I've cleaned the data. I've dropped missing rows and then duplicates. Then I want to play it to see my data, my clean data information. This is just a little code to be able to do that. Right. So this is just a preamble of what the things we'll be looking at. We'll be looking at this evening. Okay. So I have a table here. I always like to make sure that there are illustrations so that by the time you are going back to the notes to go read the notes, you understand what we'll be talking about. So when you look at the aspect of missing values, when you talk about raw data that is before pre-processing comes in, you have multiple NANs. What are NANs? Not available. You have not available what? Numbers or not available numerical values or blanks. After you clean the data, the missing values are imputed or either dropped. You see those things today. Then data distribution. Is it highly skewed? If it's highly skewed, what do you do? When you clean the data, you have it as been normalized or what? Or transformed. Do you have outliers? Are they extreme? You know, there are extreme anomalies when you have your raw data. But after that, outliers can be capped or what? Or removed. Do you have categorical encoding? Okay, in your data set that is raw, there's mixed strings. You know, I've told us that what you must have what? It's either you have all strings in a data or you have what? All numeric, all integers in a data. So the data sets for processing or for machine learning ready model must all carry what? The same data type. And you must remember that every time your model will only read in numbers. Numbers. So that's where encoding comes in. So you see, after you've cleaned, you have what? Consistent numeric encoding. Then duplicates. Do you have repeated entries? We remove duplicates was when we clean our data. Future naming. Is there inconsistent casing of spaces? There are times you find out that in your columns there are spaces amongst your naming. So what do we do? We standardize what's the naming condition. Is it ready? When you check your raw data is never suitable for an MM model input if you have not carried out what? Data processing. But after data processing, that is the data has been cleaned, you see that it's ready for training and evaluation. All right. So what are the examples of LML ready data? Like what I've just discussed there. So using them, the outlines and study objectives for tonight. You have missing value like NAN, then you have an imputed value. You have an outlier, which is almost like 909, and where you're having maybe 10, 15, 20, 25, and you have an outlier 909. Are you capping it with using the quartile method or what? Then categorical value, do you have yes and no converted to what? 1 and 0. Skewed, is it skewed to the right or to the left or to the middle? Then we use what we call a long transform. You'll be seeing all these tonight. So this is just an intro to what we'll be doing tonight. All right, so we're starting with dealing with skewed data. Skewed. You hear me say skewed. What is skewed data, or what is skewness? So skewness measures what? Asymmetry of a distribution. When you see that, it becomes very ambiguous. When I was teaching this some weeks back, somebody was telling me, said this English, says skewness means what? Or measures asymmetry of a distribution. So I brought it down to us now, to my own self also. How do I understand what skewness is? So that I want to explain it to you. I say skewness tells you which side of your data leans, which side does your data leans to? Okay, so where's your data leaning to? Whether there are more extreme values on one end, or if the data is nicely balanced around the middle. Just as simple as that. You have a data and you want to plot a graph on the data. Is the data set leaning to one angle, or is it at the middle? Is it forming a nice, a nice curve, or is it to the left, to the extreme, or to the right extreme? So you see what skewness looks like. So that's what everything that I've said here, this grammatical jargon that I put there, skewness measures asymmetry of a distribution. Which side does your data lean toward? Look at it. What is skewness? This is just it. If you look at this now, this is where our data, but you realize that our data is leaning what? To the left-hand side. And so this is what? A negative skew. Please pardon my drawing. I realized when I've done that it was very small, so I had to just enlarge it. So you can see that this is a negative skew. Then when it leans to the right, extreme, you can see this looks very balanced. It gets here, it's balanced. It's supposed to come down. Can you see at this level? Then you have a balanced data set, but immediately you have anything that begins to go extreme. So this is a positive skew. So it skews to the right, it's positive. It skews to the extreme left is a negative. So that's what skewness is all about. So you can see when you are checking for skewness, how do I check? I want to check my price and see, okay, is my price list, is it a balanced? I have concerning the data set I found. So you could, there's something called a library called sci-fi or sci-pi. Sci-pi, you can call import skew from that. And we'll take your price histogram and print the skewness. You can print the skewness of your price to say, okay, what is the price range for the products that we have? Is it balanced based on the market value and things like that? Or based on current level of inflation? Is our price list, is it balanced? Or is it to the extreme negative? Are we losing, or we are making more than what we should be, or we are cheating or things like that? So it helps in financial forecast for, for companies to see, are we really serving the best, or our price, is it too high, or is our price too low? Against production, cost of production, and customer, well, how would I call it, also satisfaction and things like that. So it's just that, so you can see how in our practical class, please, I will encourage us that this week we try as much as possible not to miss a practical class, because we didn't have the last one, which I apologize for, even though the message was sent earlier on. So for our Friday class, we will be having both the class that we missed and this practical class. So I apologize once more. So you can see this skewness code snippet. You'll be seeing that as we go on. I'll give you some set of data and tell you, can you plot what the skewness for me? Let me see what it looks like. All right. So what are the tools you use in detecting skewness? I say when you want to check whether your data is balanced and lopsided, exactly. If I ask you data lopsidedness, I'm still talking about your data skewness. So skews is skewed. So you can use these three main tools. You have the histogram. Histogram, very quick visual check. Histogram is one of the quickest way to check if your data is skew. Then you have what you call the QQ plot, the quantile plot. When I think I was asking in the class yesterday when I was talking about quartile and quantile. So somebody was telling me we're talking about what? So we are looking at in percentages in in what's when you divide into parts. So I'm having it in four different parts. It's supposed to be quartile, not quantile. It's supposed to be QUAR, quartile plot. So please I'll correct that. It's QUARTILE, QUARTILE. Then you have the df.q function where you want to check a numerical what data, purely numerical data. You want to check the skewness for purely numerical data. You have your what? You use your df skew function. All right, let's go to the histogram. Histogram is like a bar chart that shows how your data is what is distributed. How do you use this? How do you use it? If the histogram looks like a hill that leans more to one side, your data is what skewed. And I showed you like an example. So when you have you plot a bar chart or a pie chart, and you find out that when you try to draw a curve over it, there's a lean towards one area, either to the left. So I say if the tail is to the right, you know that you have what a right or a positive skew, which I explained earlier on. Then if it is to the left, you have what a negative skew. All right. So now look at the code to plot what? To plot your histogram. You want to plot an histogram for your data. You want to check the income. This is just simple. We import the library called what? Matplotlib, which is the pie plot. So for those of us that were in the beginners class, I explained to them, when you have import, you are saying you are calling this library. This is a library to plot a graph. And when you see the word as PLT, it means that for this very long, this long library, you are referencing it and giving it a nickname called what? PLT. Then why do you need a Seaborn? Seaborn allows you what to also what to pick the elements of those of the particular what column or row that you want to plot. So you call SNS. So Seaborn is also what? It's also a plot library for you to plot your graph and pick those values from the table and add them to the X and Y axis of the row. So I said, what interpretation do you get when you plot this? If you have a balanced U shape, you have a balanced U shape, it's just very balanced and there's no too much movement to the right or too much movement to the left. It means that your income graph is balanced, and what that means that there's no skew. But just again, you get it to the extreme right, it's a right skew, which is called positive. Then to the extreme left, it's a left skewed, which is a what? Which is negative, which is negative. All right. Then the QQ plot, I said it's a scatter plot that comparing your data distribution to a perfectly normal bell-shaped distribution. You'll see when you do it, it looks like a bell. When your distribution is normal, you see it in your scatter plot. You can bring out what a bell. You remember the bell we ring in school when it's time for us to go for break or change of lecture and things like that. You see the bell shape. All right, doing this, you'll be able to see that. So how do you use it? If your dots follow the diagonal line, the data is roughly normal. Yes, you have a diagonal line. You draw it. When you plot, you have a scatter plot. You draw a diagonal line. So every data that follows that diagonal line, we call it roughly. But if the dots curve away from the line, you have skewness. Immediately you begin to get all your scatter plot begin to form like what? You begin to go away and move away from the diagonal line. You have what we call skewness. So QQ plot does that, the quartile plot. All right. And this is the code for you to do the quartile plot. So you can see here, it says what? You can see interpretation of your quartile plot, yeah? That's going to be, for you to use your, what's it called, your quartile plot, you will need what? To import your sci-fi, which is your scientific Python library for you to use the stats. So you use the scipy.stats. Then you need your matplotlib library to be able to plot your graph. So look at the interpretation. Maybe you see a curve going upward. There's an upward curve from being away from the diagonal line. You're having like something upward, then you say what is a right what? It's a right skew. So it means well, that is a positive skew. Lately, the curve begins to come downward. It's giving you like a downward curving. Then it's a negative skew, which is also called what? The left skew. Okay. All right. Then we now talk about what the df.skew function. I said this is a built-in method that tells you how skewed your data is when you are using what numbers. Exactly. When you are using numbers. And how do we read it? Because when you are trying to check income, we take the column income and want to check the skew. And we say, okay, print the skew, print df.skew for us for this income. If our values are equal to 0, we say what? It is symmetrical. So when something is symmetrical, we mean that it is balanced. But if your values are greater than 0, then we have a right positive what? Skew. And if they are lesser than 0, what? They are a left skew. Negative. So you can see that all of them almost follow the same rule, but they are used the what? Differently. But they almost follow the same rule. You're always having whether to the left or what? Or to the right. So quick summary, which I love doing. I love doing this so that every time you are getting to see, to know what you are doing amongst tools or methods you are using. So what are the tools we've spoken about for handling skew? We've talked about the histogram, the quarter plot, and the df.skew function. So I said, what kind of type? This is a visual type. It shows you the shape of your data. And what are the libraries we use? We use the matplotlib and the seaborn. Then you have the quarter, which is also a visual type, but always shows you what? A deviation from the normal curve. So you see how a normal data looks like. Then look at the library we use. We use our library, the scipy.stats. Then your skew is only used for what? Numeric data. Always remember that. Your skew function, your df.skew function is only used for what? Numeric data. And we are checking direction and degree of skewness. Who can remember what I said? How do we read skewness for what's it called? For your numeric data. So quickly, just like we did in our class yesterday, I have 10 points to give out. So let's start again. So when it is 0, please use your chart box. When it is 0, what does it mean? When it's equals to 0, when you are using your df.skew function, when it is equals to 0, what does that tell us? When it's greater than 0, what does it tell us? And when it's less than 0, what does that tell us? Quickly, I'm waiting for the fastest finger. We are talking about handling skewness using what? Your df.skew function. Can we go ahead quickly? I say, how do you interpret it? When you have equals to 0, we say it is what? I just need a name. Tell me, just write on the chat box 0. Okay, I will start with 0. I will start with less than 0, then the next, you guys, fastest finger will give me orders. So when it is less than, this is what it means. This is what it is. Left. Let's go to the left skew. All right, so the remaining two for 2 points this evening, quickly. Are we all here? I'm waiting. I'm not going to call names at all. So I just need somebody to answer. I just explained them the df.skew, which is for numerical value. And I say when it is less than 0, it gives us what? It gives us a left skew. So I need the remaining two answers quickly. Let's go on. Okay, let me see. What is that? Okay, so Joseph says 0 means symmetrical and greater than 0 means skewed. So we'll be taking points down. So Joseph, you have 2 points this evening. So 2 points, as we have 8 points left for this evening. So just note that for the points that for yesterday's class, I forgot to tell them, which I will reiterate. For those points, I will be adding them to your final capstone project. So it's possible maybe your capstone project got something like 86. And if you have gotten points of like 4 or 5 points, it means that you have a 90, which is a perfect and excellent result. So Joseph, you have 2 points for this evening. So let's go on. Thank you. Please, let's be interactive this evening. Let's use our chat for this evening. Okay, so when should you transform? When you're talking about skewness, now, we've talked about skewness and things like that. And the next question that should come to our mind is, okay, when do I need to transform a skew? When I see a data is skewed, or yes, or my data set is skewed, where do I need, or when do I need to transform? The first thing is when you are using a model which is sensitive to what distribution shape. When you are using models that are sensitive to distribution shape. Some models assume your data looks like a bell curve. Yes. Some models are so good like that they just assume that it's taken. But if you're not careful, there will be issue of overfitting. Your model will overperform and it will not give us the right generalization. So I say some models assume your data looks like a bell shape. Then if your data is heavily skewed, these models can become biased or inaccurate. They don't have filters in them. There are some models that have those filters in them that they never assume that your data or that your data is bell curve. They already have inbuilt functions for themselves that when they get to a data, they test for skewness before training the data. But there are some models that are like that. There's nothing. You need to help them undo what skewness. If not, you have a bias or inaccurate result, or we call it bias or variance. And look at this model type. When you have any linear model, the first thing you need to know, all linear models, they are very, very sensitive to skewness. So you need to transform. Every time when you're using your and I just gave you, instead of saying linear, so I gave you an example, your linear regression model. You need to transform. The same thing with your logistic regression model. You can see. So sensitive to skew, yes, you need to transform. Then you have your k nearest neighbor and your support vector machine. They also do the same thing also. You need to what? You need to transform or scale. Neural networks, somewhat, I put somewhat, some of them, you don't, not most times they move to skewness. So all they always do is that before you even get to that stage, you have already from the stage of preprocessing. So that's what we'll be working on. You'll see that for this class, I'll start with working with you with what's it called? With numerical data. By the time we get to deep learning, we'll start working with images. So we'll start first starting with transformation. And you'll see that we'll get to a place after the first 4 weeks. By the time I'm moving to the next 4th week, we'll start talking about deep learning, talking about pre-trained models like ResNet, DenseNet, EfficientNet, mobile VNet, and all those. They are all neural networks. So often normalized. So you will have, even before you can get to see skewness, because you have done normalization on those data sets, you hardly have skewness. The only thing you can have is an imbalanced data set when one section of the data is it has much more weight than the other one. And we have things that we call like random samplers and then the smooth analysis. You'll be seeing them as we go on. But when you see decision trees or random forest trees, all these three models, when I mean 3 models, they use a lot of connectors. They are never susceptible to skewness. Usually they don't need transformation because they already undo transformation on their own. So you find out that when you have data set that has skewness or outliers, you want to undo those data when you use decision tree models. You use 3 models like your decision tree, your random forest, use your SG boost. Exactly. Those kind of models are so fantastic to handle outliers. So you won't need to do a lot of but how do you know that my data is not skewed if you have not tested? Because most of the time, yes, decision tree models and random forest models might be good, but they might not be the desirable model for that kind of data set. So you need to test, and that's why I'm showing you the steps on how to test for to test for skewness. All right. When should you transform? When the data has a long tail. You remember I've told us what the long tail means. Is that is dragging to the left so much, extending to the left or to the right. So I say if you plot an histogram and you see a long tail on one side, like income and prices, the larger values dominate and can mislead your model. Yes. If you're not careful, your model thinks that, wow, it means that a lot of boys a lie. So you can see an example. I say most people earn between 30K to 60K. And if you earn 1 million, if you're not careful, your model tends to go to where you have those that 1 million because they have a larger kind of a figure. So it means that your mean and variance becomes very huge. If you're not careful, you have an high variance and the model will never perform. It's like it's underperforms, which or it overperforms. So it's that it's underfitting. So when I say underperform is underfitting, overperform is what? It's overfitting. All right. So what transformation helps in this kind of place. All right. Then when you want to stabilize variance, so if the spread of your data grows as the value increases, transformation can make variance more constant and improves your model fitting. Yes. If the high level of variance, well, those okay. I think maybe I'll be releasing some of my notes for you guys also for beginners, maybe some videos so that you can watch some of those videos and see what a variance does and how you undo variances. Then when you need normal residuals, what do you mean by normal residuals? You are checking your model for errors, and those and they are not normally distributed. That's a red flag. When you are checking for errors, and one of the things is that errors are never normally distributed. It's so funny that they will be hidden somewhere. So it's better to just transform your input or target variables from the beginning. So that's why I advise data. That's why you find out that data cleaning, or let me just use the word data preprocessing, is one of the greatest, how would I call it? It's one of the fundamental, exactly, that's the word, fundamental criteria for you before you even start talking about training your model and evaluating your model. Immediately your data is not well processed, problem has started. In fact, you are already creating a bias system. You are creating a bias system as it is. Right. Then lastly, when you need to compare variables on similar skills, exactly. You want to see some transformations help bring very different skills closer together. Useful when you are working on clustering or distance-based algorithms. You see that when you are doing clustering, we have supervised learning. We've seen all these things like called supervised learning, unsupervised learning. You are working on a clustering model. You just need to do a transformation. Okay, you have data sets, and some data sets are hiding on one angle, some are below the angle. You need to bring them together. So you need to bring them together so that they can work very well for you. So by the time you are creating your models, and that's why most times you find some people, oh, I built a model, my model's accuracy is 99%. The model accuracy is 99%, but when we look at your precision is like 60 something. That means that the model is not precise. There's something is wrong somewhere. Somewhere something is hiding somewhere that was not well treated before the data was fed into the system. Okay. All right. So what are those transformation methods that we need? You have what you call the log transformation. The log transformation. The formula is what? S bar equals log of x plus 1. This only works with positive values. So you have your positive, your skewness, moving towards an angle. How do you bring the positive that are going to the right extreme? Bring them back to form what? So you pick those values one after the other. So the value, we have positive. From the negative, we have a -6 to the 0 point. But from 1, we have 1 to 13. How do you bring those guys to come together to form a bell shape? So all you do is that you put them in this, what's it called? In this formula. So this is that's why I was telling some of the guys I was training some months ago. I told them that when you look at what's happening behind data science, you see that there are a lot of mathematical and statistical, what's it called? Annotations, but which Python has been able to help us to reduce. Can you see that this telling you to go and do a log now? If I give you the paper now to do log of 14 plus 1, it might be very, very hard. But all we need to do is just call the function in what? In Python. Can you see df, the income log equals to what? mp.log1, one decimal place or whatever you do. And before you know it tells us and brings all areas that are skewed, brings them together, and we have what? A bell shape. All right. Let's go on. You have the square root and cube root also. You have this is moderate. Maybe your skew is not so much. So you must understand where you need. So I'll be trying to feed us some data set that might just have moderate skew. You need to know where you need to use this method. So for the first method I told you, to the extreme, positive values. Then when you have moderate, it's not too much to the left, too much to the right. You use what you call the square root and the cube root and the cube root method of transformation to transform your data set. You'll be seeing this in our practical class. All right. Then you have the box Cox, called the box Cox transformation, the power transformation to stabilize variance. Especially when you notice variance in your model. There's variance in your model. And when there's issue of variance, your model is underperforming. But when you have bias, your model is always overperforming. So anytime you hear variance in data science, we are talking about what the model is not performing to what the extent. So something is actually happened during the data, or maybe the data is too small for the model, or the model is not good for the data, or something happened during data preprocessing that we didn't do well, and that's why you need to you need to transform these data sets. So you can see the code. So these are codes that you'll be seeing. By the time you go through this lecture again and go and see it yourself, you just understand what they are doing. So we say from Cypher start, as I told you, you can import. So I told you, I said now that you start importing libraries, you realize that your scikit-learn library has a lot of embedded libraries in it to do a lot of functions. So we have, at this stage, we'll be going beyond Panda and NumPy now. We're calling libraries that can perform preprocessing, standardization, calling of our models, error detection, and a lot of things like that. All right, then you have the Johnson transformation. You can see now, I was expecting somebody to have put, but I love you guys. You guys were so patient with me. When I talked about what works on positive. Who can tell me what works on the positive? You can remember, you can see that Yale Johnson transformation works on 0 or negative values. Who remember what kind of transformation method works on positive values? 2 points already to Joseph this evening. Quickly, fastest finger, quickly. I'm waiting for us. Don't let Joseph take the day today. He already has 2 points. Joseph again, another 2 points, log transformation. Thank you, Joseph. So log transformation handles positive. So for your negative or your 0, you have the Euler-Johnson transformation, which works with 0 or negative values. So when it's towards extreme to the left. So I'll be giving you data sets that will be like that. So how do you first know? You must first view. And I've told you those kind of the tools for first viewing to be sure if your data is skewed or it's not, it's normally distributed, or is it that skewed to the left and skewed to the right. And I think we spoke about 4 tools. We spoke about about 4 tools, your histogram. We spoke about your QQ plots. Who can tell me any other one? Any other one quickly before we go on? I'll go on while you are thinking of it. You can just put it on the what's it called? On the chat. All right, so let's see a quick summary. I love doing this. When we talk about something, I love giving you guys fallback tables. So even if you don't remember what has happened, you can come back and look at it. So you can see now when we talk about the methods for handling skewness, we have the log, we have the square root and the cube root, we have the Bob Cox and the Yale Johnson. Handles negatives, you can see that log does not handle negative, it handles positive. Square root also handles moderate. Then Bob Cox does not handle negative also. Only your Johnson handles positive. What is the strength? Log is one of the strongest. Square root and their bit is medium. Bob Cox is adjustable. You can also push it for what? You can use it sometimes, but it's mainly, but the best of them is your Johnson. Very flexible. You can handle mixed sign data. When you mean mixed sign data, we are talking about a mixture of your string with your integer or whatever it is. So this is very positive. You can see Bob Cox is just positive. The square root or cube root is for your moderate. Then log is highly skewed which is to the positive. So this is a quick summary table for that. All right. So we've been able to talk about skewed data. How do we check if a data is skewed? Then we also saw methods for transforming skewed data into normal data. Then the next thing that happens when we are talking of advanced data processing techniques or strategy is how do you undo missing values? Sorry, excuse me. How do you undo missing values? It's one of those things. I've seen somebody said, delete it. Just delete the whole row. No, don't delete the whole row. You might cause problem and you have maybe that row you are deleting might just be the row that has the what? That has the strongest attributes that gives that data set meaning. So you can't delete or just drop anything without checking. So what I'm missing, how do I have a missing value? What? Overview. What is a missing value? The data entries with what? With no record dead value. And this is the code to check. When you want to check your entries in on your data frame or your data set, you use the df what dot is null dot sum. So it tells you how many rows and columns are what are without what recorded values. So you know that there's a missing value somewhere. Very, very necessary before you begin to even do anything. Even before looking at if the data is skewed or anything, we must talk about what missing values. How do we undo? We have a record of about 10,000 patients, and out of 10,000 patients, 7,000 of them have a missing record in their diagnosis. How do we undo that? Or in their treatment? Let's use the word treatment. And the word treatment, how do you now know? Out of 10,000 to a patient, 7,000. So it's very, very necessary to know. So, and what are those kind of missing values that you have? I put them in table for you. You have the MCAR, call it the MCAR, which is the missing completely at random. What does it mean? Data is missing purely by chance. There's no pattern of this thing. You've checked. Maybe there was a pattern. Maybe something went wrong somewhere, or maybe somebody was a mistype. Or no, you realize that the data, maybe something just happened randomly. Maybe somebody forgot. And what is that kind of scenario? If you survey responses accidentally skipped, yes, it's possible, human error. You are giving somebody to go and, you went for a survey of about 10,000 people. Then somebody comes with a file as higher than me as I'm sitting down and tell somebody to impute it into the computer. There's no way. It will surely randomly or somehow. So how do you detect it? Random distribution of what non-available across all variables. There's no correlation with any future. Yes. And that's where your histogram comes to play. Your histogram can detect a lot of things, not skewness alone. You can look and say, why is this particular? Maybe it's just treatment. You plot your bar chart. You're finding that no, something is just wrong. Why is every other one, they are going this way. And all of a sudden the guy just drops down. You're wondering something is happening. There's no correlation. So how do you undo it? Common handling strategy. The safest is to drop or impute what? Your mean, median, or mode. Since missingness is what? Is random. Well, you must first test that is it random. I always advise don't drop. If you drop, especially for medical, you can drop for other data set and realize that you can drop for all the data set and you are doing very, very well. But if you are not careful with medical data set that I work on, which is my area of specialization, if you drop some row, you have destroyed the data sets. Actually, you destroy. So what we do at that time, what I do most of the time is I use main median mode to undo that. I'll just look at okay. Then what's the mode? And how do you get the mode? I was teaching those that were in what's it called? Your main median mode. I was teaching them in their class yesterday for the beginners class. I said you have what you call the df.describe. It just gives you the statistics of the whole data set. It calculates your mean for you, calculates your 25 quartile, 50 quartile, 75 quartile, calculates your mean median mode for you, and it calculates your standard deviation using that code. So from that, you just use it to impute what? The area that is missing. And you find out that your data set will actually work very well. Then apart from the MCAR, you have the MAR, which is missing at random. Missingness is related to other variables, not the values itself. What is that scenario? Income missing more often for younger people. Can you see now? So it's not related, it's related to younger people or certain regions. So can you see the difference between this kind of missing values now? So it means that you must be able to read your data very, very well. before you just start anything. Don't just pick up a data and yeah. So how do you detect? Say missingness shows a pattern when grouped by other columns. Exactly. You check it by other columns and say, okay, what is happening in this region? Why is this region for this region? Are they missing data set? So how do you do that? There's something called predictive imputation. We'll be talking about it, or a regression or KNN mice model for you to do that, for you to undo this kind of missing at random. Then you have the MNA, which is the opposite of the MCA. MNA say missing not at random. Missingness depends on the value itself. The fact it's missing carries information. Maybe people with very high income refuse to report it exactly. So you realize that in a scenario in the income, you find out that, oh, people have like two groups with a 30K salary and things there, but you don't find anything again. You get to regions that you expect that it should be more than 30K, and you're seeing them having something like 5K, and you're wondering, no, or there's no even record at all. So how do you detect? The pattern persists even after controlling for other features. Requires what? A domain insight. So you now need to do a research and call whoever had gathered the data set. What really happened here? And at that stage, what do? We create a missing flag or the model missingness separately. So I'll show you how we do all these things. We create a flag immediately for this particular region and set of people. This data is missing and we will not be able to use it. So we create a new column and call it missing data or missing values and things like that. So it's missing not at random. It's was purposely omitted because some people don't want them. And this is what the tax officers do. So you find out those tax officers that are good with data analysis and data forecasting. That's what they do. They just know that this region, like Banana Island, how come we cannot see their income? Because people don't want anybody to want. So purposely, they won't report the income. So the survey goes on and it doesn't pick the right data sets or the data features or the data values. All right, so what are the basic strategies? Deletion. Number one, drop rows and columns. I say very risky. I don't do it anyway. I'm always very scared to drop any rows and columns. So what do? I do what you call simple imputation. Simple imputation, which I can replace those values, missing values, with the main median mode. Okay, I get to age and I see the age and some age are missing. So how do I get the age? Use the mean. For everywhere you find other ages that are missing, then use the mean age or the median, dependent on the data size. So in here, this is just a simple code. We call the column age. Then we fill the non-available age with the median. We say in place where median is true. So that's what it means. Where you have already calculated and the median is true. So you use that. We could use mean when it is true and things like that. So this is the first, these are basic strategies that we do when we find out that, okay, they're missing and okay, we can do that. I will always advise you guys, never try as much as possible. Don't drop rows and columns until you have satisfied that, okay, it has no effect on the data set itself. All right, then we go to advanced strategies. I call it what? The mice. The mice, multiple imputation by changed equation. Yes. So the mice leads you to your KNN imputer, which is called the K nearest neighbor. It's based on your nearest neighbor. So we look at the nearest neighbor. Okay, we are seeing missing values. Maybe we'll be having values. Then we see a missing value. Okay, what's the nearest value that was there with it? Okay, impute it with the nearest value. So it shouldn't be too much. Impute it. Or we use a predictive model, train a small ML model to estimate the missing values. Yes. We can just tell it, okay, go through this column and the values in the column and try to predict or just estimate what could the missing values be in these 10,000 rows. So you can use what you call your... are you trying to say something? Aderonke? I can see your chat. Maybe it's just a mistake. Okay. All right, let's go on. So you can create a small ML model that can do what? Missing value that can help you calculate what? Missing value. All right. So this is This is good. This is good. Okay. Then you can add what? Another thing is called what? Add what? Missing indicator. So instead of just filling in your missing value, you can add a new column that marks where the value was missing, like a binary indicator, and say, okay, 0 is that it is present, and 1 is that it is missing. So I say add a binary missing value indicator for the age column. Yes, you get to a age column and call it okay. You can add a new column to say, from age, we realize that a lot of data were missing. So what are the number of data missing? You see the next table that comes in. Okay, look at it now. For every place that we age 35 or the age range, you can see where we say, okay, where we have age. Can you see what I've done now? So we create a new column to say age. It makes use of data. I wouldn't be similar to, yes, like central tendency. God bless you. Fantastic. Central, thank you, Joseph. That's very good, like a central tendency, yes. So you can see we bring a new column into near the age column to say, okay, for where there's age, what we give it a 0, we assign 0 to it to say, okay, age is present. Therefore, where there's no data, we call it what? Or no value, we say 1. It means that it is missing. Why does this help? If you see on the right hand side, it allows your model to learn patterns in the missingness itself. And it's always very particularly useful when the data is what? Is missing, not at random. Maybe, purposely omitted. And it can boost your model accuracy when missing values are informative. Yes. A lot of places in Africa, some people don't like to put their age. They say, they want to know my age. That small girl that they told her to come and do survey. Why would she know my age? They won't put their age in the form. Say, now she'll be looking at me somehow. Things like that. So cultural biasness and things like that. So you can undo using a missing indicator. So mean is like central tendency. Thank you, Joseph. So when you're using mean and things like that, so since it carries the central tendency of the data, it's enough to fill in, but it's always very difficult and dangerous to use sometimes to test mean when the missing values are just too much. So it's always good to use add your missing indicator. Your model will learn from that, and you'll be so surprised that your model will perform very well. So I said the new column called age missing tells your model where values were missing. Tells you where values were missing. All right. So moving away from that, we go into detecting and handling outliers. We want to detect and undo and outdo outliers. What's an outlier? Excuse me. I said data points that deviate significantly from the rest. Okay. Hold on, please. Let's pause. I can see a question here. Go on. Just like the question Joseph have just asked, so that maybe for those of us that want to get back and watch the video again. So he says what happens if a user purposely enters a wrong value? Is there any countermeasure? At that moment, the first thing you need to do is for like age, and I use age for an example, and you've done the age group and you realize that there's no age group like 9 years old in your age group. You've done, you've converted to age group. You can do that. Most of the times I do those for my age, for my data when I work with age. I create, when you have a column age, I create a column called age group and say, okay, please put them into age group. From there, I can detect I can detect missing values or detect wrongly written value. All you need to do is delete that data. It doesn't meet it now. If the age group is starting from age 18 and you have something 9, 5, no, they are not part of that population. The only time they are part of the population is when they are in the age group and they carry a very large number. You imagine if you are starting from 18 years old and the only thing you can see is 9 and 5. Then what happened from the age of 12 and things like that? So those are the things you need. Informed meaning you look at it. No. And if they are no more than 3, 4, just delete them and go on with the highest population that you have and your age group. Do we get that? All right. So outlier, you see outlier. I told somebody one day, was asking me, how do you explain outlier? I say outlier is the black sheep among all other sheep. So that's the best way to explain an outlier to you, is a black sheep. So you will see it now. outlier with plot plus. I checked plotted a box over my data set. Look at it. Everybody, I told you draw a line across. You draw a line across your what? Across your X and Y axis. Anything that deviates to this is an outlier. Can you see? It's the black sheep. Look at every guy. Oh yeah, it's either on over or below. They are still what along this horizontal line. That means that the data are correlating. But anything that goes beyond this place is a problem. Only this guy can cause problem. If you use this guy with this data set, it can cause problem for the whole data set, and the model can overfit or underfit. That is underperform or overperform. So anytime you hear the word outlier, just remember the black sheep. The black sheep. So that's it. It leaves other people and other tenders. Can you see? There's still curve. There's supposed to be a curve here. If I draw a curve, there's a curve here. It's still not within the curve. It's still not within the curve. Can you see? It's just far away. Too far away. So it's an outlier. So what are those outlier detection methods? How do you detect what? Outlier. You have your RQR method, which is called the interquartile range. You have your Z-score method. Then you have the visual multivariate method. Those are the ways we can detect what outliers. Okay, so what is the RQR method? I said the RQR method uses the spread range of the middle 50% of your data to find values that are usually high or low. Exactly. So anything, it uses the quartile. You know, I tell you, when you do your df.describe, you get your 25 quartile, your 50 quartile. So most of the time, RQR method uses the 50% of the data. It looks at, okay, what is the correlation of 50% of the data set itself? So it now uses that to find what the values that are usually high. Okay, an outlier that has gone above or what has gone below. So let me give us something. Look at it now. Can you see? So percentile, your 25th and 75th percentile. So this is your formula. If there's an outlier, if what? If it is less than what your quartile 1 minus 1.5 plus your 50% of the what? Of it. So you do that. Anytime you want to know that there's an outlier, this is the formula. For it being high, this is a formula sorry, this is a formula. The first one, you say it is a lower quartile when you have your QRA minus what? 1.5 times your RQRA. Or it's great when you have your third quartile plus your what? 1.5 times IQR. So all these are just statistical what? So how do you get your IQR? Is your what? Is your third quartile or your third percentile minus what? Your first percentile. So we minus, okay, 75 plus 25, you get 50. So it's always 50. So maybe the value we have here is maybe 10. So we say 10 minus 1.5 times 50. The value we have here is like 10,000. Say 10,000 plus 1.5 times what? 50. So you know your board mass now. Board mass. So your what? Subtraction multiplication comes before what? Addition and subtraction. So just remember that. But the good thing, about Python is that we have a code for that. You and I don't need to be cracking our brains. You and I don't need to be cracking our brains to what? To start to do all this calculation. So you can see my quartile here. Can you see my code? So we have the difference in salary. The quartile in our salary, we look at the quartile of salary row. So I've already referenced it. Then I call it filtered. So I want to know if there's an outlier. Is there an upper or lower outlier? So I call my DF salary and I do my quartile minus. And you see, I put it in what's it called? In Python. All I need to do is say what? Print df underscore filtered. And it tells me the quartile to the left and what to the right. Is there an outlier to the left? Is there, or how much to the left? Or how much to the right is there? Is there an outlier? So you can see that we'll be able to undo both left and right, or both and left and right outliers. All right. So please, you'll be noting this down. I think we are the only ones that have not done assignments because we missed our last class. So the first assignment, which I will share the note to you, I want you to create like a dummy data yourself. And I want you to do a plot box to show me how to undo an outlier from your data. So if you have a data, you can create a data frame of one salary. I say salary equals what? 100K, 200K, 400K, then I have 10,000K. Then what? I say whisker extends to limits dot beyond whisker. So I want you to do caption any point beyond the whisker are flagged as what? Potential outlier. So I just want you to try and plot a graph of an outlier by creating a data frame with data that has outlier in it. Give me a box plot of it. So I'll leave you to figure that out, even though I'm going to show it between our practical class, but to be able to pour this out. So this is just the assignment within your work. All right. So the Z-score method. The Z-score method measures how far a value is from the average in terms of what standard deviation. If something is too many standard deviation away, it is what? An outlier. That's what Z-score does. So when you look at your standard deviation and the value of that term or that object or that feature is more than what the standard deviation is, too far away from the standard deviation, then it's always what? It's always an outlier. And this is how you calculate your sorry, excuse me. This is how you calculate your formula. So your formula gives you your Z-score, which is equal to your X. Your X is your data point minus your mean and your lambda, which is what your standard deviation. So can you see? So if Z is greater than 3, you know, when you calculated it and your Z is greater than 3, it's always what? An outlier. Anything, if you have looked at it, meaning that if your standard deviation is what? Is 3 here, I just give a typical cutoff. Maybe your standard deviation is 3. Really, you calculate your mean, and for that particular data points, maybe the data point you saw is among 100,000, 200,000, and you want to use it, and you do this calculation, and it's giving you something greater than your excuse me, than your standard deviation, then excuse me, you know that it is an outlier. Can we just pause the presentation so that I can take water, please? Let me pause the recording then. Let's take a short break of about 2 minutes so I can take water. And you can stretch your legs and arms. Okay, all right, guys, welcome back. Welcome back. Thank you for the short break. Just needed to take water, so let's go on. So we've spoken about our accurate method. We talked about the Z-square method. Now we go on to the third, look at the code for the Z-score method. So you can see that. So we call the SciPy library. We import stats. Then we enter what our stats and tells it that standard deviation, any salary from that outlier, the salary figure, which is either less than 3 or higher or greater than 3, is what is an outlier based on our standard deviation. All right. So also your assignment 2, I want you to give a normal distribution curve centered create a normal bell curve with cut points. You have a normal distribution curve centered at a mean of 0. Vertically dashed lines at minus 30. Yes, your standard deviation minus 3 and plus 3. So I want to see the extreme. Shade the extreme end tails to show outlier zone. Label, you have your normal range, then the ends. So your center should be your normal range. So you can use 2 different colors. Then wherever is extreme should be. All I'm saying is that just create a dummy data and plot something like this. Let me have a figure that you can plot. All you need is create a data frame with a data set 10, 20, 30, 40, 50, 1,000 or minus 1,000 or something. Then plot the graph and let's see what it will look like. All right. Okay. Let's go on. Then you have what you call your visual and multivariate method. I said some outliers cannot be spotted by one column alone. Yes. From some column, you can just see, oh, no. There's an outlier. But some, you will look at it, you can't. You need to look at combination of variables, like age versus income, or height versus weight. Can you see now? So that's what is called visual. Visual is that you have to look at it. You are the one that will first spot it from you cannot spot it from one column. You spot with what combination of columns, either your age versus income, or age versus disease diagnosis and things like that. height versus weight to detect points that don't fit what the group pattern. So that's what your visual and multivariate method does. So I said, look at the methods. What when you talk about its method and visuals, you have to use the scatter plot first. So a simple visual for 2D relationship, dot showing that one variable versus another or isolated dot is equal to outliers. Yes. So you might need a scatter plot, a 2D scatter plot, to be able to check using two different columns to be able to know. Then there's what you call the Mahalanobis distance. This is for statisticians anyway. It measures how far from the point is how far a point is from the center in a multivariate space. So you have like an eclipse contour. Looks like an eclipse, like here, what with distant dots highlighted there around it. So most of these times it's extreme data sets that have this multivariate, you use multivariate for. And you have what you call the isolation forest, when you use your machine learning algorithm that isolates anomalies. So you can have a scatter plot with what red anomaly points, yes. But it might not show, if you first do your normal, so you need to call these plots to use your isolation forest plot, your Mahalanobis distance, or your scatter plot. But most of the time, scatter plot reviews, most data that I found that scatter plot always reviews what? Reviews the outliers. You can see the one I showed you there, the scatter plot. It reviews outliers immediately. So most times you don't need to go through to use a Mahalanobis distance or isolation forest. All right. So look at it. This is a code for your isolation forest. So I just pick the isolation forest. So you can call isolation forest from your scikit-learn ensemble model. So let's look at it. So this is the model isolation forest. So contamination is between 0.5. So want to define outlier. Help us check outlier between what? Age and income. So if the outlier is -1, it's flagged as anomaly. But if the outlier is equal to 1, then it stands between what? The normal data point. So it's just, you can see these are mathematical things being converted into what? Into our programming. So we'll see how these things work out. I hope I'll be able to get a data that we can use isolation forest for. If I can't get, I'll create one so that in our practical class you can see that. All right, so for your visual, for your multivariate, I made it an assignment also, but if you cannot, so I want you to do what? You want to do a scatter plot, or you use an isolation forest to automatically detect the odd ones that are out based or on how easily they can be isolated. But I don't do the isolation forest, just do a scatter plot for me. Plot y-axis age, then blue dot for normal, red dot for what? Detected outliers. So you can create a data frame yourself also. All right, let's go. So handling outliers, like I tell you, how do you undo? We've spoken about methods to detect outliers already. So how do you now handle outliers? Strategy, these are 4 strategies that we usually use. We say remove, when to use, when there's data error, like what Joseph was asking me. Wrong entry, just remove it. You see that when you ask me if the user purposely enter wrong value, don't bother yourself. You are not the one that made that mistake. You remove. Then you have one thing we call the Winsorise. When do you use it? You want to keep the structure. Just like I was expecting, I was telling you, cap it at what? 95th percentile. I didn't talk about Winsorise, but after this, I'll talk about Winsorise for you. And it's one of those, but you hardly use Winsorise. Then you have a transform. When we're talking about skewed, you have skewed data, you can apply your log or what, your square or cube root model. Then you have leave it. I'll put it there, leave. True extreme cases, they are genuine rare events. You can't do anything. You leave them that way. You leave them. So when you are talking about health challenges, when you're looking at issue of breast cancer, you find out that some people are at stage 4. You are trying to do prevalence of breast cancer, and you have patients that are just early stage, you have stage 1, then you have somebody with stage 4. You can see that it's a true extreme case. It's a genuine rare event at stage 4 cancer. It's not how would I call it? It's not an outlier. It's a condition that the person who were here, it's not a condition that somebody is happy or in. So that's what I was trying to explain to us. And when it comes to health data sets, most of the times, not everything is being seen as what outlier. Not everything is being seen as outlier. So you just leave that. Somebody has breast cancer is a first stage, stage 4, or prostate cancer is a stage 4. There's nothing you can do. You can't bring that. You want to manipulate, you can't manipulate the data set at that state. It's just quite unfortunate. So these are some things that are very, when we are doing our data analysis on some data sets, you just find out that you just wonder, wow, a lot of people are going through a lot. So you just leave it the way it is and use it to train your model so that your model can understand that this is not an outlier, but it's just a genuinely rare event. Okay, so what is that Wins Horizon I was talking about? I say Wins Horizon means limiting your extreme data values to reduce the effect of outliers without completely removing them. Yes, you can do that. So instead of deleting very high and very low values, you cap them at a certain percentile. So you calculate which percentile at your 95th percentile. So that's what Wins Horizon means. We don't want to remove them. We need them. Is that 100? No. Okay, what is our 95th percentile? We cap everything to the 95th percentile. So you can see, look at this data set now. Look at this example. Let's say you have salaries. See the salary, 30,000, 35,000, 45,000, 40,000, 45,000, 50,000. Can you see 2 million? 2 million is an extreme. I said the last value, what is 2 million, what is an extreme, is an extreme. So after Wins Horizon, you might cap all the values that are above the 95th percentile, say 60,000 to what, to 60,000. So that's what we do. So we now say, okay, at least this is the, okay, 90th or the 95th percentile should be 60,000. So all we do is that any value that is above 60,000, or is above, is almost very extreme like this. Look at the example I gave. Before Wins Horizon, we say 30K, 35, 2 million. So after Wins Horizon, what we do is we call 30K, 35K, 40K, 45, 50. You can see that the 2 million has been has been changed to what? Has been changed to. So no data is deleted. You just pull in the extremes. That's all. You pull in the extremes. Then you put it in your report. And that's why it's good as a data scientist. You're always reporting. Oh, during my process of carrying out data preprocessing, I saw some data sets that were extreme as outliers. I used Wins Horizon or visualization to undo them. So you put it there and you tell us how many features did you undo with visualization, or how many data values did you undo with that, and things like that. So it lets us know, okay, all you've done is everything capped at 60K. We have the extreme value. So that's just what Wins Horizon. That's what Wins Horizon is about. All right. Then can you see how your Wins Horizon code looks like? So visualization, or you visualize your salary by capping bottom 5% and top is and bottom what, and top 5%. Can you see it now? So we now say what our salary is visualized. Then we'll call it's got to visualize the DF salary. Then we limit anything that is what, if it's in the extreme of the lowest also. So you cap to the 50th percentile and to the 95th percentile. You get it right. So it's like saying anything too small or too big, push it closer to the what? To the rest. So just imagine when I go back here and when we're having 35K, we have somebody who had 200 naira. So we bring the person to the fifth. So to the fifth, we say 30K for that person. So I will just bring those data. But sometimes you have to be very careful, because when it comes to some financial, you are very careful. You might have, done something wrong and influence the data set wrongly. So you must first ask, okay, who got this data set, what happened, and things like that. So you must do your investigation. That's why you find out that a good data team will always consist of the data collection team, the data preprocessing team. And so you have the team so that you'll be able to understand where is this data coming from and things like that. So visualization is also a very good, let's go. And it's one of the easiest when you look at it. It's one of the easiest. All right, can I just pause for 5 minutes? I have a call coming in, please. Just give me 3 minutes and I will undo it and get back to us, please. Sorry. No, please don't leave. I'm sorry about this. Pause, everybody. I really apologize. Sincerely apologize for that. So this is what winsorization, this is what winsorization does for us. You can see that you can bring an extreme value and pull them in from both what the lower or what or anything too small, anything too big. All right. Then we'll go to what encoding categorical data set. You know, I told us the computer system cannot cannot understand, only understands in numbers, in numerical values, especially when you want to prepare your data set to be ready for what? For LME classification task or prediction task or whatever task you are trying to carry out. So we need to encode your numerical data. All right. So what is encoding? So encoding means what? Converting categorical, that is text or label-based data into numerical form, so that your machine learning models can understand and process what? And process it. It's as simple as that. That's what we are doing. We're encoding. We're encoding. So what we are converting, just say you are transforming. Let's use the word. I'm transforming from what? From one data type to another what? To another data type. All right. So why do we need encoding? Why do you need encoding? Most machine learning algorithms, especially when you are talking, I was telling you linear regression, your logistic, your SVM and neural, they work with only numbers. They always work with numbers. You hardly see, or unless one will start getting to your deep learning models that uses images, that uses clinical records, exactly. So that at that moment, you can use text, you can look for, in fact, it uses a description of a patient ailment to carry out, but those are deep learning models, not your machine learning models. When you talk about like machine learning models, they need to encode. They only work with what? Numbers. They can't interpret text like yes, blue or I. So you need to help them. Encoding helps to translate this qualitative data into a format that the model can use. And that's how you realize that for every time you are creating a model, you talk about what? Quantitative data. So quantitative data, they are coming what? In numbers. They are not coming in either strings or Boolean or statements. No, they are coming in what? In quantitative, that is in numbers. So data that needs encoding, like I've said earlier on, I just want to show us some data that needs encoding. You have your binary category, like we have yes or no. You need to label and encode. So that you are calling yes 0 or no 1, or where you have female and male. You see those kind of things. Or you have sick or well, or how would I put it? Infected, not infected, things like that. You need to encode them. So the encoding approach is always to give them 1, give them zeros and what? Zeros and 1. Then you have your nominal category, like your country, your color. You have what you call the 1-hot code, the frequency or target encoding. Then you will see the ordinal category. We have to do with maybe 3 types of category: low, medium, high. You can also use what you call the ordinal or integer encoding. But most of the time, for most of my I use what 1-hot coding, and the basic coding just convert to zeros and 1. So I can also call low, and say low is 0, medium is 1, and high is 2. One of my journals that I just wrote, working on a sickle cell anemia severity. So I divided severity into what? Into mild, moderate, and severe. And I encoded using 0, 1, and 2. So for anywhere my model sees 0 for prediction, it knows that what? The severity is mild. And for everywhere it sees 1, it knows that severity is moderate. And for everywhere it sees 2, it knows that's what? The severity is severe. So this is what data set that we can encode. All right. So look at an example of those coding that I told you using Panda. I've created a data frame here. I said gender is male, female, and male. And I did color and what? Red, blue. So for my gender, I want to encode my gender. I encoded my gender using what? The label encoding, which is the simple, very simple encoding, just change to 1. What did I say? I say what? Change gender encoded. I pick the gender column and map them. I do a mapping. Say what? Male is equal to 1, female is equal to 0. Some people can say male is equal to 0, female is equal to 1. Always just make sure. That's why I always tell us, and I tell my students, and I tell myself too, which I've taught myself. For every time I write a code like this, you will see me put a comment underneath or a docstring and say, so that when I'm remembering, so that in case somebody else comes in, I say I'm converting here. I write a lot of statements to say what? I'm converting the gender into, so you can see label encoding, and I put a gender conversion from male to 0 and things like that. Sometimes when you master programs, some people don't comment anymore. But for reusability, which I'm teaching the advanced class, I tell them about reusability. We talk about commenting and things like that. So maybe when you get to advanced class, you also be able to learn that. Then look for color. You use what we call the one-hot encoding. So the columns, you'll see what it looks like when you put them on a table. When you do a normal labeling and a one-hot encoding. So I say, well, get dummies of color. So I could change a color and say the color could be what? You just change the color to something. You can give it 0 and 1 also, and say red is 1, blue is 2, or I can give it a binary number and say red is 001, 010, 1100, or something like that. So you just encode them with a different. So anywhere you see red, red is always referenced as what? 001. That's what encoding. You know what I mean? When you are one hot, so I'm putting something specific, something unique on what? On color. So can you see now? So when I say, can you see now? When I say male, I say when you see color blue, can you see now that I've encoded a male can you say a combination of the encoding that I did? Just let me go back so you understand what I did here. So I say a male can have what? Red, blue, green, and red again. So if it has red, I say, okay, let's make red 0. You can just place it on it. So he understands anywhere he sees red, but most of the time, it's not always good to program like this. I don't really support somebody programming like this. I'll prefer that since you have said male is 1 and the female is 0. For coding a color blue, just make color blue, say 03 or something. Make color green 04 and make color red 01. I hope you get what I'm 02 or something. So that there won't be confusion, because when you come to this table now, you see that somebody will say, how come is a color blue carrying 0 and things like that? So it causes confusion. So it's better to what? To always just make sure that when you're encoding what properly. All right. So the encoding methods I was talking about, your ordinal encoding, which is normal, your one-hot coding, your frequency count encoding, and your target mean encoding. We're almost coming to the end of the class tonight. So when you see ordinal, I say what? Natural order that exists. Your low, medium, and what? And then high. So you can do that for quality. What's the quality of a good? Or like I told you, severity. Mild, so you can use your ordinal encoding. So you encode, you call what you call you can see that I told you, scikit-learn has a lot of what? A lot of libraries. It has a processing library where you can import your what? Ordinal encoder. So immediately you are saying quality, it knows immediately that you are transforming quality. And quality always has what? You see that quality is carrying low, medium, or good, or it's carrying excellent, good, or poor. So later you can now specify what you want to do. So that's your ordinal encoding. So you can tell it how you want to break down the quality. Should it give me low, medium, or high? Or should it give me poor, good, and excellent, or fair, or whatever metrics you want to use? There are no natural order exists at all. You want to encode a city. There's no natural order for that. So a city you can have Ibadan in how would I call it? Ibadan city in another place, maybe in Kano. I'm just giving an example. So you can say you should give it dummies, you can see. So you just give those cities dummy names. Give cities dummy names. Anywhere you see Ibadan, call it maybe IB or something, just give them dummy names. So that's one hot encoding, you can see. So most of the time, I don't like using one autoencoding because if you are not careful, you can give two different value features, the same kind of what code, and you might miss it. You might miss it out. So you have to be very, very careful. Then when you talk about frequency count encoding, you are replacing a category with its frequency. That's all you are doing. So look at for that city now, it's better to use the frequency of that city. So you create a frequency map and you count. So now you encode and say what you map those cities with their value counts. Can you see maybe the way it has been arranged here, Kaduna comes first or something like that. So you now use the account to map those cities. So I think that is even better. But you must always put a comment. That's one good thing. Say, okay, what I'm doing here is what a frequency encoding based on the accounts. I have created the cities based on their accounts. So it's as easy as that. These are things we'll be testing on as we go on. Then you have what you call the target mean encoding. A supervised encoding that uses what target averages. Yes. Like category. You can use category and you can use a mean, the mean of those categories to tag some categories. This rarely happens, sir. This is really for salespeople. For those of us that will be working on sales data, you might need to encode you find some category. Maybe you have categories can be different. You can have children, yes, fashion, and things like that. So you might need to encode them. So how do you encode categories? So you can use mean, or we call what you call the target encoding. All right. So let's look at some things. 3 slides left anyway. So the encoding type, you have the ordinal, the one-hot, the frequency, or the target. Does it preserve order? Yes, the ordinal stays with order. One-hot, and it doesn't need any order. Target also works with order. Does it undo high cardinality? Can you see what I told you? So you have to be very careful. Handling high cardinality. Ordinal and one-hot code will not. So you can see the risk of leakage is always very low for them. But when you are doing frequency and target, if you are not careful, there will be data leak. What is data leak? Some data would not correspond with what you have done. And it will give you what? It will give you a model problem. To give your model big problem. There will be data leakage, data loss, and leakages. And if your data is already exposed to your model before training, then the model will just overfit. That's already learned even before training it. Then it doesn't make sense at all. All right, so these are our key takeaways for tonight. Skewness, anything that has to do, always make sure you apply suitable transformation. Then when you have missing values, advanced imputation or you flag it. Then outliers, you detect and decide whether you want to remove, you want to trim, or you want to transform. Then when it comes to encoding, choose appropriate strategy and be aware of leakage. Be very careful that you don't have data leakage. And this brings us to the end of our class for this evening. I don't know if there are any questions or any area that you need me to touch in the next 5 minutes before we call it a night. Any question? Any area? This is the time to use our
okay, good.
Our
Thank you.
box. Okay, go on.
Yeah, thank you for the